Chalo, let's begin. The last discussion that we had was with respect to uh, how to tackle a situation on limiting factors using linear programming. We had one question where we actually plotted lines on the graph paper and we understood how the linear programming model actually works. We understood the corner point theorem and it was a very long discussion. But as I told you, a discussion on reading the graph is more important than a discussion on making the graph, because in your PM exam, they are not going to ask you to make the graph. They are going to ask you to read the diagrams that are given. So the next questions are going to focus on that aspect. But I firmly believe that in order to make any graph properly, you need to understand, sorry, in order to read any graph properly, you need to understand how exactly is the graph made. Hence, we spent time on doing one full length question using a graph. Now, let's look at this question. It says formulate the linear programming problem and solve the question using simultaneous equations. Okay. Hebrews manufactures summer houses and garden sheds. Each product passes through a cutting process and an assembly process. One summer house, which makes a contribution of 50, takes 6 hours cutting time and 4 hours assembly time, while one shed makes a contribution of 40 and takes 3 hours of cutting time and 8 hours of assembly time. There is a maximum of 36 cutting hours available each week and 48 assembly hours. Cutters are paid $10 per hour and assembly workers are paid $15 per hour. Formulate the linear programming problem. First of all, whenever you have a situation of linear programming, even if you don't have to plot it on the graph, or you just want to find out the optimal solution, the first step should always be to define the variables. Okay, that should always be the first step. Variable is something that varies, something that changes, something that you don't know exactly right now. And what do you not know exactly right now? You don't know how many units of summer house should be produced, which is one product, and you don't know how many units of what is the other product? Summer house, which makes a contribution of 6 cutting hours, and while one shed. So there are two products that you are going to produce. You don't know exactly how many units of each should be made in order to achieve an optimum production. Okay, let us produce X units of the summer house and let us produce Y units of the shed. Okay. Let us produce X units of the summer house and Y units of the shed. The second step should always be to define the objective. What do you want to do here? You have defined the variables. Now you need to define the objective. What should be the objective? Objective could only be maximizing the profit or maximizing the contribution or minimizing the cost, but cost minimization questions are usually not, or rather never asked in the uh, linear programming part of limiting factors. So our objective should either be to maximize the contribution or to maximize the profit. Here they have given us figures in contribution terms, not in profit terms. So the objective should be to maximize the contribution. Okay. So the objective should be maximize 50x plus 40y. Okay. What is 50? 50 is contribution you make for the summer house and you are making X units of the summer house. So total contribution is 50x and you are making Y units of the shed and contribution for one shed is 40. Step 3 is now you have to define the constraints. Okay. Define the constraints. Now, what exactly is constraint? Is a limiting factor, something that stops you from achieving your full potential. If you observe what is in limited quantity, the cutting hours each week and the assembly hours each week are in limited quantity. ठीक है, we could write down the product, which is summer house product, then name it summer house and shed. And we'll also have to define how much time does it take in each of the departments. Okay, we know the number of units. We have jotted those down. We are making X units of summer house and Y units of shed. Now, what is the cutting time per unit? Total cutting time is limited. Okay, cutting time per unit. And what is the second activity? Second activity is assembly time per unit. Cutting time per unit. And guys, 1 second, just 1 second. These are the two activities, cutting and assembly. When you do cutting, see what they have given here. One summer house, which makes a contribution of 50, takes 6 hours of cutting time. Cutting time per unit, 6 hours. And 4 hours of assembly time. While one shed makes a contribution of 40 and takes 3 hours of cutting time and 8 hours of assembly time. So we have defined now how much time each unit of summer house takes for cutting and for assembly, similarly for shed. Okay, now what is the total cutting time if I'm making X units of summer house and it takes 6 hours of cutting time, and I am making Y units of the shed and it takes 3 hours of cutting time per unit? What is the total cutting time? Total cutting time is 6x plus 3y should be 6x plus 3y is the total cutting time. And what is the total assembly time? Total assembly time is 4x plus 8y. ठीक है. Now, total assembly time is 4x plus 8y. There is a maximum of 36 cutting hours available each week and 48 assembly hours. This is the total cutting time that will be required. Okay, rather this is the, I should say this is total cutting time required and this is total assembly time required. We also know what is the maximum time available each week. So our first constraint will be defined as 6x plus 3y. Let's insert the symbol here. 6x plus 3y less than or equal to 6x plus 3y less than or equal to 36. Okay, and 36 cutting hours and 48 assembly hours. So what do we have here? We have 4x plus 8y less than or equal to 48. Okay, now these are our two constraints. Apart from that, there is also the non-negativity constraint.
No, sir.
Yes, hi.
Sorry to interrupt. It should be 6x plus 4y.
Why should it be 6x plus 4y?
Can you scroll up?
Cutting time is limited, right? One unit of product summer house takes 6 hours of cutting time.
And
One
4 hours of assembly time.
हाँ बट समर हाउस का टाइम लिमिटेड नहीं है ना, कटिंग टाइम लिमिटेड है. व्हाट हाउ विल यू अराइव एट टोटल कटिंग टाइम? नंबर ऑफ यूनिट्स ऑफ एक्स इनटू कटिंग टाइम पर एक्स प्लस नंबर ऑफ यूनिट्स ऑफ वाई इनटू कटिंग टाइम पर यूनिट ऑफ वाई. ऐसे आएगा ना.
But I think आप थोड़ा
टू. हाँ क्या करूं, बताओ.
scroll up.
बताओ.
like 6 hours of cutting time and 4 hours of assembly time. So it
Yes.
should be 6x plus 4y.
No, but the question is, we are not asking na कि how many total hours are required for summer house. वो थोड़ी limited है. 36 cutting hours limited है ना. तो what summer house will take for cutting and what shed will take for cutting, उन दोनों का total मिल के आएगा ना. आपका cutting time limited है. How what is total cutting time required? टोटल कटिंग टाइम रिक्वायर्ड इज समर हाउस के कितने यूनिट्स बने एक्स. एक यूनिट को कितना टाइम लगा 6 आवर्स. तो टोटल कटिंग टाइम कितना हो जाएगा 6 इंटू एक्स 6x हो जाएगा राइट. एंड शेड के कितने यूनिट्स बने वाई यूनिट्स बने. एक यूनिट को कटिंग टाइम कितना लगता है 3 आवर्स लगता है. तो टोटल कटिंग टाइम कितना हो जाएगा 3y हो जाएगा. कटिंग टाइम इज 36 आवर्स. प्रोसेस का नाम कटिंग टाइम है, प्रोसेस का नाम समर हाउस नहीं है. सो टोटल कटिंग टाइम रिक्वायर्ड विल बी 6x + 3y ना. हाउ कैन इट बी 6x + 4y. और 6x + 4y तो हो भी नहीं सकता.
Okay, sir, understood.
क्लियर.
Yes.
Yes. And because we are making summer house and we are making the shed, these are all units or items, hence these both have to be greater than 0. So the non-negativity constraint is the next constraint. Now this is more or less a given कि आपका नॉन नेगेटिव all items have to be greater than 0 number of units produced, but still it's an important point that you mention the non-negativity constraint everywhere. ठीक है. So with step 1, step 2, step 3 you have defined the variables. What is it that you want to make? You want to know what is the best combination of units. So when you make summer house you don't know how many, you don't know कितने यूनिट्स बना के you will get the maximum possible production. And you don't know shed के कितने यूनिट्स बना के you will get the maximum possible contribution. So you assume that it is x units of summer house and y units of the shed. And what is the objective? The objective is to maximize the contribution, which you have done 50x plus 40y. Okay, step 3, define the constraints, and you have successfully finished that step also. Now you will have to solve step 4. You'll have to solve the simultaneous equations. So how do we solve? We have two equations here. We'll ignore the less than sign and we'll write it with just the equal to sign. 6x plus 3y equal to 36 and 4x plus 8y, sorry, 4x plus 8y equal to 48. Okay, this is my equation 1. This is my equation 2. Now let's solve. If we have to solve, we'll have to, eliminate one of the variables. So 6, we can decide to either eliminate x or we can decide to eliminate y. I want to eliminate x. So to eliminate x, what should I do? To eliminate x, multiply equation 1 by the, if you want to eliminate the variable, you have to basically get the least common multiple of the two. 6 and 4 ka least common multiple is 12. So multiply equation 1 by 2 and equation 2 by 3. So what will be the resultant equation now? If I multiply equation 1 by 2, I have to multiply both the sides. So it becomes 12x plus 6y equal to 72. And multiplying equation 2 by 3. So here I'll get 12x plus 24y equal to 48 into 3. So now I have my two equations. 12x plus 6y, and 12x plus 24y. Now it's easier to eliminate the variables. Okay, I'll do equation 4 minus equation 3. 12x plus 24y minus inside the bracket 12x plus 6y. 44 minus 72. So 12x plus 24y minus 12x minus 6y gives you 72. Okay, now 12x will get cancelled. I'm left with 18y, sorry, 18y equal to 72. So that gives me y is equal to 72 upon 18, y equal to 4. Now I have to substitute y equal to 4 in one of the equations. Okay, substitute y equal to 4 in equation 1. 6x plus 3 into 4 equal to 36. So 6x is equal to 36 minus 12. 6x is equal to 24. X is also equal to 4. Okay. Substitute y equal to 4. So what is the optimal solution? Optimal solution says make 4 units of summer house, 4 units of summer house and 4 units of shed to get maximum contribution. So you first of all define the variable, define the objective, define the constraint, and then you solve the simultaneous equations to get what you can perceive as the optimal production plan. Now, this is one of the easier questions that can be asked in the exam, and this can come as a multiple choice question. Section A में आ सकता है where instead of it won't be a fill in the blank, they will have multiple choices: 4 units of x, 3 units of y, 3 units of x, 4 units of y, so on and so forth. So that is ideally how such questions will be structured. Okay, let's attempt another one. Chalo. Following, formulate the constraints for Alfred company using simultaneous equations to accurately calculate the quantities produced at the optimal point and calculate maximum contribution at this point. Again, this is a question on simultaneous equations. Alfred Company is preparing its production plan for the upcoming month. It manufactures two products, flag trap and sap trap. Details are as follows. They have given you all the information on the two products. What do I mean by all the information? They have told you what is the selling price per unit, what is the raw material required in kg, the rate per kg, the labor hours time, skilled and semi-skilled. The company's fixed overhead absorption rate is $1 per hour for both skilled and semi-skilled labor. The supply of skilled labor is limited to 2000 hours per month and the supply of semi-skilled labor is limited to 2500 hours per month. So you know what is the limiting factor. At the selling price, maximum demand for flag trap is expected to be 150 units per month and maximum demand for the sap trap is expected to be 80 units per month. So there is an upper limit also. Beyond that, even if you produce, you will not get any market demand, so to say. So usse zyada also if you produce, you won't be able to sell. So that is the upper limit. Now, You want to know what is the optimum production plan or what is the best production plan, and when is the production plan the best? When you maximize the contribution. So step one that you have to do here is still you will have to define the variables and you will have to define the objective. Objective would be to maximize the contribution, but if you can see, they have not given you the contribution directly. They have given you the background data. So your first step would be calculation of contribution per unit. Okay. Particulars. F is flag trap. S is sap trap. I have just used the initials. So first of all, let us write down the selling price per unit. This is given to us in the question. 125, 165. Okay. Then raw material requirement in kg. Raw material required in kg. 6 and 4. Oh, sorry. 6 and 4. And C will be raw material cost per unit. How will I get it? By multiplying B, which is the requirement, into rate per kg, which is phi is the rate per kg. Okay. So this into phi and this into phi. Okay. Similarly, we'll have to calculate the labor cost as well. So we have we have calculated the raw material cost per unit. Okay. Now let's write down skilled labor hours per unit. You need 10 hours of skilled labor for each, and therefore you can get skilled labor cost. How do you get skilled labor cost? D, which is the number of hours, into 3, that is the rate given here. 3 per hour is the rate. So this into 3 and this into 3. F is unskilled labor hours per unit, 5 and 25. This is again given here, and rate per unit is also given. So unskilled rate per hour is given. Unskilled labor cost would be F into 3. So now what do I need? I need my total variable cost for making this. Okay, so EFGH. So I will need my total variable cost, which will be material cost rho C plus skilled labor cost rho E plus unskilled labor cost rho G. Okay, so raw material cost per unit 30, skilled labor cost plus unskilled labor cost. Okay, now what I have is I have selling price per unit and variable cost per unit. Can I get contribution per unit? Of course. Contribution per unit will be rho A minus rho H. How do I get it? 125 minus 75 and 165 and minus 125. Okay. Usually in the previous questions, the contribution figure was given to us. Here the contribution figure is not given to us. Okay. So we calculated the contribution per unit. Now the point is these two items, which two items? The number of skilled labor hours per month and the number of semi-skilled labor hours per month are limited. Those are defined. So we'll have to make an attempt now to solve this particular part. Step 1 may let us define the variables. S- Step 1 would be define the variables. How do we define the variables? Let X units of flag trap be made and let Y units of sap trap be made. X and Y we have defined. Step 2, define the objective function. Define the objective function. ठीक है. Objective is to maximize the contribution. Okay, so how do you maximize the contribution? That means my objective would be 50x because I'm getting a contribution of 50 here, and 40y because I'm getting a contribution of 40 in sap trap. So maximize 50x plus 40y. Step 3 would be to define the constraints. ठीक है. So product units, skilled labor per unit, and मैंने unskilled लिख दिया यहाँ पे. It should be semi-skilled actually. The question does not say unskilled, the question says semi-skilled labor. ठीक है. Skilled labor per unit and semi-skilled labor per unit. ठीक है. If the product is flag trap, second product is sap trap. I'm making X units of this and Y units of this. Skilled labor time 10 and 10. Semi-skilled labor time 5 and 25. 1 unit of F takes 10 hours of skilled labor. 1 unit of F takes 10 hours of skilled labor. So X units of F will take 10x hours, and 1 unit of S takes 10 hours of skilled labor. So Y units of S will take 10y hours. ठीक है. So total skilled labor time will be equal to 10x plus 10y. Okay. Total time is 10x plus 10y. And so if I am talking about total labor time, it is 10x plus 10y, and the supply of skilled labor is limited to 2000 hours per month. So maximum hours available are 2000 hours. So how will you define this? You will do 10x plus 10y is 10x plus 10y is less than or equal to 2000. And similarly, this is the first constraint. Second constraint would be 5x plus 25y less than or equal to 2500. X and Y are units of a product. So X and Y both have to be greater than or equal to 0. Okay. So I have my total skilled labor hours, I have my total semi-skilled labor hours, I also have my non-negativity constraint. So now step 4 is I have to solve using simultaneous equations. Solve using simultaneous equations. 10x plus 10y equal to 2000. This is my equation 1. And 5x plus 25y is my equation 2. Now I decide to eliminate x. Okay. So I need, if I need to eliminate x, I need the LCM of 5 and 10, which is 10. So I will say multiply equation 2 by 2. So what I'll get is 10x plus 50y will be 2500 into 2, 5000. This is my equation 3. Now what I should do is I should do equation 3 minus equation 2. Sorry, equation 3 minus equation 1. So 10x plus 50y minus 10x ब्रैकेट में 10x plus 10y. This has to be equal to 5000 minus 2000. So क्या बचेगा? I'll have 40y equal to 3000. So y will be equal to 30,000 upon 40, 75. Okay. So once you get y equal to 75, substitute y equal to 75 in equation 1. We get, if we substitute y equal to 75 in equation 1, we get x equal to 125. There are two more constraints actually that we actually did not write. That the maximum demand for flag trap is expected to be 150 units per month and maximum demand for sap trap is expected to be 80. So apart from the non-negativity constraint, there was a constraint or a limitation on the maximum units that can be produced. So we'll write it here. This has to be less than 150 and this has to be less than 80, which if you observe is the case here. So that means x equal to 125, y equal to 75 is our optimal solution. Okay. X equal to 70, 125, y equal to, okay. So this is how you will solve a limiting factors wala question using simultaneous equations. We saw two questions today, both of them slightly different from each other, but still giving you ample idea on how can questions be framed. In this one, you had to calculate the contribution, then everything else was as usual. In this question, the contribution was given, you straight away had to jump to solving the question. Okay. Write down the objective function and the constraints for J Farms Limited. Recommend the quantity of each type of fertilizer which should be bought and cost of these amounts. Now, if you want to identify what should be the variable, read the question. What are they saying? Recommend the quantity of each type of fertilizer. ठीक है, दैट मीन्स एक फर्टिलाइजर का टाइप है टाइप एक्स, दूसरा फर्टिलाइजर का टाइप है टाइप वाई. You have to decide how much quantity of each fertilizer type should be used. ठीक है. Find the saving J Farms Limited can make by switching from its current policy to your recommendation. Okay. J Farms Limited can buy two types of fertilizer which contain the following percentage of chemicals, type X and type Y. Nitrate, phosphate, potash are three ingredients or three chemicals here. For a certain crop, the following minimum quantities in kg are required. Nitrates 100, phosphate 50 and potash. This is what is required in kilograms. Okay. What is given above is percentage. Type X costs 10 per kg and type Y costs 5 per kg. J Farms Limited currently buys 1000 kg of each type and wishes to minimize its expenditure on fertilizers. ठीक है. So करंटली टाइप एक्स फर्टिलाइजर का कॉस्ट है 10 पर केजी. टाइप वाई फर्टिलाइजर का कॉस्ट है 5 पर केजी. इट करंटली बाइज 1000 kg of each type and it wishes to minimize the expenditure on fertilizers. Okay, you know that there are certain minimum quantities of fertilizers which are needed. You need 100 kg of nitrate, and you need 50 kg of potash, and you need 50 kg of phosphate, and you need 40 kg of potash. The question is asking us recommend the quantity of each type of fertilizer. तो कितना fertilizer खरीदना है of each category, that is my variable. ठीक है. So step 1 will be to define the variables. ठीक है. Let us produce x units of, or let us produce नहीं, uh, let us buy x kg करते हैं, units नहीं करते हैं, x kgs of type X fertilizer, and let us buy y kgs of type Y fertilizer. ठीक है. We were anyway going to discuss about which कितना quantity चाहिए for each type. Okay. So that is the first thing that we have done, define the variables. Now, what do we want to do? We want to here, for the first time, we want to keep the cost under control. So far, we had not kept costs under control. We were trying to maximize the contribution. Here, type X costs 10 per kg, type Y costs 5 per kg. So, my step 2 would be define the objective function. Let us make sorry, objective function is to minimize the cost. Minimize the cost. Okay, so cost of buying. Okay. If you are buying X kg of type X, 1 kg costs 10 rupees per kg. So cost of buying X kgs will be 10x, and 1 kg of type Y costs $5. So this will be 5y. Cost of buying is 10x plus 5y. The objective should be to minimize the cost. So minimize 10x plus 5y. This is my objective function. ठीक है. So step 3, now you have to define the constraints. ठीक है. Now you have to define the constraint. You know that there are three ingredients here. What are the three ingredients? Nitrate, phosphate, and potash. So let's write down the chemical ingredient first. ठीक है. Because उसका minimum quantity, maximum quantity is for that. ठीक है. So chemical name is nitrate, phosphate, potash. Nitrate, phosphate, and potash. Now, how much do you need? Minimum quantities are 150 and 40. So let's write that down. Minimum quantity 100, 50 and 40. Okay. Now 1 kg. So when you buy type X fertilizer, it contains 18% nitrate and 5% phosphate and 2% potash. When you buy type Y fertilizer, you get 3% phosphate and 3% nitrate and 2% phosphate and 5% potash. Okay. So in 1 unit, let's not call it kg for now, in 1 unit of type X fertilizer, we have 18% nitrate. 18% is basically 18 upon 100, correct? Which is also the same as 0.18. And so in 1 unit of fertilizer X, we have 18% nitrate. So in X kgs of fertilizer X, we will have 0.18x nitrate. Do you agree that if 1 unit of type X fertilizer, we have 18% nitrate, 18% is 0.18. Whatever is the quantity, uska 18% is nitrate. Here the quantity is X kg, so uska 18% will be 0.18x nitrate. Or in 1 unit of type Y fertilizer, we have 5% potash. Okay, 5% is 5 upon 100, which is equal to 0.05. एक यूनिट में 0.05 है. So in Y kgs of type Y fertilizer, we have 0.05Y potash. ठीक है. The reason I have written this is you should know कि भाई ये how are the numbers getting calculated, because we need minimum this much nitrate, this much phosphate and this much potash. तो ये x kg और y kg में कैसे आएगा, we need to understand that, right? Now let's try to plot the constraint. ठीक है. So 0.18 of how much nitrate do you need? You need minimum 100 kg nitrate. X kg में कितना नाइट्रेट है? 0.18 x nitrate. So 0.18 x plus टाइप Y का फर्टिलाइजर जो है उसमें देयर इज 3% नाइट्रेट, दैट इज 0.03 y. ये हो जाएगा 0.03 y. देन फॉस्फेट यू नीड 50 kg. टाइप X फर्टिलाइजर में 1 यूनिट में यू हैव 5%, तो X kgs में यू हैव 0.05x. ठीक है. 0.05x plus when you make, so you need 50 kg phosphate, 1 kg of fertilizer, sorry 1 unit of टाइप Y में 2% फॉस्फेट है, तो Y kgs में कितना होगा? Y kg इंटू 2%, राइट? Y kg इंटू 2%, 2% इज 2 अपॉन 100, सो ये आ जाएगा 0.02y. एंड पोटैश 2 and 5 in 1 kg of in 1 unit of type X you have 2% potash. ठीक है. 1 यूनिट में 2% पोटैश, तो x kgs में कितना? x इंटू 2% मतलब x इंटू 2/100 विच इज 0.02. सो 0.02 x 0.02 x plus 0.05 y. ठीक है, यू हैव डिफाइंड द कंस्ट्रेंट्स, बट दिस इज द मिनिमम क्वांटिटी, सो वॉट एवर परसेंटेज यू गेट, वॉट एवर क्वांटिटी यू गेट, वो क्वांटिटी यहाँ पे आपके सारे कंस्ट्रेंट्स जो है, दीज कंस्ट्रेंट्स आर ग्रेटर देन कंस्ट्रेंट्स, ठीक है, these are all greater than constraints. This has to be greater than 100, this has to be greater than 50, this has to be greater than 40, ठीक है. And now you have to solve using simultaneous equations. अब यहाँ पे I want you to solve this on your own. I'll then of course give you the answer. I want you to be mindful of two things. ठीक है. Usually you have two variables and two equations. Here you have three variables and three equation. अब आप क्या करेंगे? Step 4 now will be solve the simultaneous equations. First of all, I'll write down the three equations for you. 0.18x plus 0.03y, 0.05x plus 0.02y. A question like this level of complexity will not come. I'll also tell you why it will not come. But this is necessary for your practice and concepts. तो आप देख लो इसमें मैं क्या बोल रहा हूँ. 0.02x plus 0.05y. ठीक है. This is 100, 50, 40. ठीक है. Let this be your equation 1. Let this be your equation 2. Let this be your equation 3. Now what I want you to do is, I want you to solve 1 and 2. You will get some solution. Get a solution. Then solve 2 and 3. I want you to practice simultaneous equations, which is why this will help. Get a solution and solve 3 and 1. उसके लिए ऑल्सो गेट अ सोल्यूशन. 1 and 2, 2 and 3, 3 and 1, तीनों को सॉल्व करो, गेट अ सोल्यूशन फॉर ईच वन ऑफ देम. एंड वंस यू गेट एक्स एंड वाई कितना कितना है, थ्री डिफरेंट आंसर्स, ट्राई टू सी विच वन गिव्स यू द मिनिमम कॉस्ट. यहाँ पे यू हैव टू मिनिमाइज द कॉस्ट. नाउ द प्रॉब्लम विथ such a, I wouldn't call it a problem, I would say a situation. See, this is your graph paper. ठीक है. Now, why this kind of question on a graph will not be asked? ठीक है, you draw three lines, line 1, line 2, line 3, whatever you draw. ठीक है. Now these are all greater than or equal to constraints. Greater than or equal to constraints मतलब, see, when it was less than, we went left or we went down. Now that it is greater than, because now it is a greater than constraint, what will happen is, in a greater than constraint, you either go up or you go right. So your feasible region will not be a closed feasible region. It will be an open feasible region. And open feasible region में naturally this 0 0 will not come. Your feasible region will be all of this area. ठीक है. और इसका कोई लिमिट नहीं है, ये अनबाउंडेड फीजिबल रीजन है. इट्स अ बिग फीजिबल रीजन. सो ये आपको ग्राफ पे दे विल नेवर आस्क यू. सेकंड थिंग, if you have, so basically when I need three intersection points, I will get three solutions, right? 1 and 2 का solution, 2 and 3 का solution, 1 and 3 का solution. अब exam में they cannot give this to you in section A and section B because it will take a lot of time. They can ask this to you in section C, where your ability to tackle simultaneous equations will be important. तो वो आपको करना है. You get some answer to 1 and 2, 2 and 3, 3 and 1. वो तीनों x and y के जो भी आपके आंसर्स है, सब्स्टिट्यूट देम हियर. विच एवर वन गिव्स यू द मिनिमम पॉसिबल आंसर इज द solution set. Also remember one thing, ये open feasible region का rules are a little different. Those are not a part of our syllabus. ठीक है, इसीलिए if such a question comes, it has to be solved only using the simultaneous equations wala method approach I have given you. In the exam, at best, what they can do is they'll give you two equations in section A or section B question. If at all they ask this to you in section C, they will have to give you three equations and then it will be a long calculation per se. ठीक है, so keep that fact in mind. ठीक है.